Today, we want to continue looking at our double and triple integrals, and we have changed shape to a cone. So we want to find a double and triple integral for the volume of a cone. For the double integral, I'm going to set it up as a dx dy integral. Once I set it up as a dx dy integral, we will simultaneously be working on the triple integral dx dy dz, or dz dx dy. Let's first think about what the double integral will require. If I'm going to set up a dx dy integral or an r dr d theta integral, I want to look at the top view to see what values from the xy plane or the r theta plane will be plugging in. So the top view will inform us the integration parts. What are we plugging in to our expression? So if I set up dy dx over here on the, I just have to go to write down what's x between, and x goes from negative a to positive a. So here's x equals negative a, and over here x equals positive a. For what's y between, that's where we're going to have to grab the circle. So if I pick a typical x value and see what is on the bottom and the top, I'm going to have plus or minus the square roots of a squared minus x squared. So up here at the top is where y is equal to the positive square roots of a squared minus x squared. Down here at the bottom is where y is equal to negative square roots of a squared minus x squared. So we've set up this dy dx integral. The next part is to figure out what z is between, and for that we're going to need to move to the side view. And we have these two functions. From the side view, we're going to try to figure out what z is between. So we need the bottom and the top from the side view. So we can see that the top part is just where z is equal to h. The bottom part is going to be that absolute value shape. So the top is the line z equals h. And then the bottom is got to be that the V shape. So on the left side, on the right side, we have z equals the h over a times x, and over on the right side, z is equal to minus h over a times x. So we've got this plus and minus h over a times x. Got these two different bottom The thing that we want to notice here is that we've got a plus and minus. We want to notice that the shape is an absolute value. We have this plus and minus shape. And we also want to notice that we have this absolute value shape. So it makes sense that the equation for the volume for the cone is not z is equal to plus and minus the square root of x squared plus y squared. Oops. I just kind of instinctively wrote down the volume of a cone. We know if we have z equals just plus and minus I'm mixing two things up. So we know that if we have z equals x squared plus y squared, this will make the sides parabola shaped. So z equals x squared plus y squared will make this parabola shaped. If we want to flatten those out, if we want to make a linear relationship between where the circle is and the value of z, then we need to put the circle and the value of z on the same exponent. Oof, I really messed all this up. I don't know if this is a more coffee problem or a less coffee problem, but I know which solution I'm going to apply. So for the equation of a cone, we know that if we just have z equals x squared plus y squared, that's going to have the side shaped like a parabola. Look at the relationship between z and the circle. So the x squared and the y squared are both, the x and the y are both squared, but the z is just to the first power. So when y is equal to 0, when y equals 0, we have a parabola, z equals x. What we want is z and x to have a linear relationship to make this absolute value sign. So what I'm going to do is I'm going to bring the power of z up to the same as the power of x. For the cone, I'm going to write z squared is equal to x squared plus y squared. Now z and x have the same power. So that if I try to write my equation of the cone as a function, I end up with a plus or minus square roots of x squared plus y squared. So z equals x squared, that makes a parabola shape. I want the z and the x to have the same power. So I raise the z up to squared. I have a z squared equals x squared, and that's going to give us our v shape. Because if I try to write a function, z is equal to plus or minus the square root of x squared. And that's what we want. We have z equals minus x and z equals plus x. All I need to do now is incorporate the slope h over a. And that's just going to be our coefficient of the circle. So what we want, what we're getting from, what we want is the top to be this line z equals h and the bottom to come from this cone. Since we're looking at values of z that are above the xy plane, I want the positive square root. So since this is going inside the function that we're integrating, we'll take the top minus the bottom. So I'm going to take h minus h over a times the square roots of x squared plus y squared. So in this setup, we're integrating the top minus the bottom rather than putting it into a triple integral. Recall that we also wanted the triple integrals for the volume of the cone. And at this point, we can see what our triple integral should be in rectangular coordinates. Because when we set up a triple integral for a volume, we're going to be integrating the function 1. And in the double integral, we have the top minus the bottom. Those are just going to be our endpoints in the triple integral. So our triple integral should have the same opening. X goes from negative a to plus a. Y will go from negative square roots to positive square roots. And we can see what the bottom and the top is because that's the thing that we subtracted to make our double integral. So the bottom is the positive square roots. And the top is just the flat line h. To get a volume, we integrate a function 1. And the order we picked here is dz, dy, dx. The first integration here would integrate the function 1 dz, and that gives us a z. Then we plug in the endpoints h and the positive h over a square root of x squared plus y squared. And that gives us h minus h over a square root of x squared plus y squared. The first stage of our triple integral gives us our double integral. This first stage of our double integral will give us one of our single integrals. Rectangular coordinates would be kind of awful in that regard because we'd have to do trigonometric substitution. Any questions? I messed up the equation of the cone part because it's early. And I was thinking about too many things, I guess. So I apologize for messing up the equation of cone. But the equation of a cone is just z squared equals x squared plus y squared. We knew that there was going to be some x squared plus y squared running around because the top view is a circle. Anytime we have stuff with circles in it, where we in rectangular coordinates, we should expect some x squared plus y squared. We also know that our life is going to be much easier in the land of polar coordinates because circles are just two intervals in polar coordinates. R will go from 0 to a, and theta will go all the way around from 0 to 2 pi. So circles are just two intervals in polar coordinates. Rectangles are just two intervals in rectangular coordinates. When you try to describe round stuff with rectangular coordinates, that's when things get messy and trig substitution shows up. But when you try to describe round stuff with polar coordinates, you just get to use intervals. Any questions? Summoning trig substitution is kind of like summoning Candyman. You look into the mirror, and instead of describing a circle with two intervals, instead of just looking in the mirror and being r goes from 0 to a, and theta goes from 0 to 2 pi, r goes from 0 to a, theta goes from 0 to, that's not going to work. So that's just rectangle. Circles are rectangles in polar coordinates. No problem, it's just a couple of intervals. But if you really want to do something terrible, like next semester in Calc, when I have Calc 2, I need to summon trigonometric substitution. So I'll be up in my office looking in the mirror. X goes from negative a to a. Y goes from negative square root of a squared minus x squared to positive square root of a squared minus x squared. I have to say that 3 times. That's why I'm late to class all the time. Friggin' summoning trigonometric substitution. It's crazy. So because our top view, where we decide what values we're plugging into the expression, is round, it's going to be a lot easier to set up with polar coordinates. Circles are just two intervals in polar coordinates. So instead of r, or instead of a and instead of x and y, I'm going to just take r equals 0 out to r equals a. And theta will go all the way around from 0 to 2 pi. Oops. So to describe that top view, the stuff that we're plugging into our expression, in polar coordinates, I just need 2 intervals. Circles are just 2 intervals in polar coordinates. R goes from 0 to a. I'm just going to take that orange line and wrap it all the way around the circle. Theta goes from 0 to 2 pi. If we look from the side view, I have the same top and bottom. So the top is just z equals h, and the bottom is just the cone. But I don't want the cone in rectangular coordinates. I want the cone in polar coordinates. So I still have h minus h over a times the square roots, but I don't want x squared plus y squared. I need to replace x squared and y squared with r squared because we're going to polar coordinates. This double integral has been set up as a d theta dr integral, but I can't just write d theta and dr because theta is not a length, theta is an angle. I need to use arc length to turn d theta into a distance. The dA in polar coordinates is r d theta dr. And we can simplify that square root of r squared with just an r. If we're going to be careful, we should note that when we take the square root of r squared, we get the absolute value of r. But when we notice that r goes from 0 to a, the values of r are never negative. We don't have to worry about the absolute values. So we're safe. This was an easy transition because the double integral in polar coordinates is still just describing the stuff on the floor. And we have the same z-axis sticking out of the pole that we had sticking out of the origin. So translating this polar coordinate double integral to cylindrical coordinates will be the same process that we used to go from the rectangular double integral to the rectangular triple integral. R will go from 0 to a, theta will go from 0 to 2 pi. And I can use the same z, but translate it into polar coordinates. At the top, z is equal to h, and at the bottom, z is equal to h over a times the square root of r squared, which we'll just simplify to r. To get a volume in a triple integral for a volume, we just integrate the function 1. The first variable we have is dz. The next variable we have is theta, so we need an r d theta. And the last one is the dr. The r is there to be part of the dv in cylindrical coordinates. But rather than writing it in the dv part, I move it over into the part that we're going to integrate. The first thing that would happen when we integrate when we integrate 1r with respect to z, I get zr, and then I plug in the endpoints h, and then h over a square root, or h over a times r. So the first step in that triple integral in cylindrical coordinates will land us on the double integral in polar coordinates. All of these were able to use the same z for the top and bottom. Just trading out the x squared plus y squared for r squared. Because both polar cylindrical coordinates and rectangular coordinates use the same z-axis. Any questions? Yes. Oh, this would be simplified. The square root of r squared would be simplified to just an r. I didn't want to write another double polar integral. Is everybody okay? That was just an example of me kind of being a little bit lazy. Which is weird because we usually decry being lazy as a vice, as a bad thing. But here's what happens if you approach your work kind of from a lazy aspect. You find more efficient ways of doing things. All the mechanization that we have, way back when mechanization really started going, kind of like your modern industrial age, people used to think, wow, if we can offload all this work to the machines, then what it normally takes a person to working 40 hours to do, they'll be able to do in 10 hours. And people actually thought, that's great. That means we'll have another 30 hours to do something else. Instead of working 40 hours per week to get the same production, we'll work 10 hours per week. So like, here's our company and y'all are my factory workers. I'm like, all right, we're going to install these machines. I got to teach you how to do all these machines. So instead of all of you working 40 hours per week, we can get the same production level with all of you working 10 hours per week. And we used to think, wow, that's going to be awesome. What are we going to do with our other 30 hours? We'll work on our poetry or our painting or our music or I don't know, whatever other things that we want to do. But instead, the boss is like, oh, or we could quadruple production. You can probably figure out which one we picked. Then y'all are like, oh, actually, we're not going to quadruple production. We're going to negotiate because all of us can walk out and then you'll have zero production. In which case I'd be faced with like, oh, so they're going to form a union. I need to stop that. So rather than try to discuss or negotiate, I just go out and hire some thugs and they come in and start beating you up until you acquiesce to my request. Or my thugs murder enough of you that you decide to break into my office and just murder me. I mean, we could go old school as far as union goes. You know what I mean? As a member of a union, I've been accused of being a union thug. I'm like, well, no, I know my history. You don't want me to play the union thug role because there's too much murder, even for my tastes. Why don't we negotiate? Do you know what I mean? Incidentally, this is why I want to pay students to be students, because I think it's a valuable thing. I think society benefits from educating its population. So I just want to pay you. And then I want the students to get together and form a union. Not like a student union where you coordinate all your activities. You have one of those as well, but a labor union where you negotiate for the conditions under which you work. Because right now it's not very effective. You just go onto some subreddit and complain about the conditions at your school. And other people just go, yeah, that does kind of suck. I would much rather you go onto your union website and say, hey guys, there's this policy and we don't think it's a good one. What do you think? And the membership says, yeah, that kind of sucks. So you bring that to management for redress of grievances and we negotiate. See? You know what I mean? So anyway. It's a little bit trickier. It's not exactly analogous because I don't have some kind of production level that I'm trying to meet. right? We're not actually producing anything, but I think a lot of times students work under awful conditions and they figure they just have to take it because they're students and they don't have any power. Well, what would the school do if all the students just decided to collectively say, fuck you, and walk out? Would the school just go on as normal? I don't think they would think it would. You know what I mean? That's why I would want you to form an official labor union, because you'd be able to do that without fear of reprisal. Because if you all did that now, I don't know, this class, you might figure that me personally, Professor Leach might get the point. It's like, all right, come back in, let's have a sit down and talk about our grievances. But you probably have a professor in mind right now that if y'all did that, they would just flunk your asses. You would face repercussions for standing up for your rights. Do you know what I mean? Anyway. That's just me, though. I would rather be paying you for all this. So the students that haven't been here for like the last 2 months, I could just fire them instead of going in and dropping them. Oh, but I got to take this class and I need this for this class, prerequisites. It's like, no, you're fired. All right. We also need to set up a triple integral in spherical coordinates, but we're going to do that tomorrow. Actually, we're not going to do that tomorrow. I'm unable to be on campus tomorrow until the afternoon. So that means I will not be holding a meeting tomorrow. So no meeting tomorrow. So you can take the opportunity. Now I'm not canceling all your classes. So if you got a 9 o'clock class, you still got to get here for that. So don't be like, oh, Leach said there wasn't fun. There's no meeting for Calc 3 tomorrow, but that does let you sleep in a little bit. It's actually not so bad. The parking isn't as bad anymore because enrollment is way down. So it used to be like a horrible mistake to get here at 9 o'clock instead of 8 o'clock. Because at 9 o'clock, there would be no parking. All the parking is gone by like 8:12. But now it's not so bad. So take an extra hour, or if you don't have a class until 12, take an extra 4 hours. That's going to do it for today. I'll see y'all on Thursday. Everybody have a good couple days. Thanks for playing.